let's talk about graphing inverse trig functions. Before we do, let's talk about what an inverse is. Remember, if a function is one-to-one and passes a horizontal line test, then its inverse relation is also a function. Now for sine, cosine, and tangent, none of these are one-to-one, so we're going to need to restrict the domains in order to discover the properties of the inverses. Now, the -1 here means inverse sine. So this is the sine of the inverse of sine is x, and this is only true when the domain of the inverse sine is -1 to 1. The inverse sine of the sine of x is x, but we're going to have to restrict the domain -pi/2 to pi/2 when we're talking about sine of x. Now, the cosine of the inverse cosine is x when the domain of the inverse cosine is -1 to 1. And the inverse cosine of cosine is x when I restrict the domain of the cosine from 0 to pi. And for the tangent of the inverse tangent is x for all real numbers. But for the inverse tangent of the tangent of x, we're going to need to restrict the domain to -pi/2 to pi/2. Now, some things to remember. A function has an inverse only if it's 1-to-1. You can restrict the domain, and after you restrict the domain, you can find the inverse. All inverses are reflected across the line y equals x. And you can graph the inverse by switching the order of pairs on the functions, much like we did on the y is equal to x squared. So, if you're an inverse, you're on restriction. So if I wanted to sketch the sine function from -pi/2 to pi/2, first let me complete this table of values. The sine of -pi/2 is -1, -√2/2, -√3/2, sine of 0 is 0, √3/2, square root of 2/2, and 1. So I've graphed y sine of x from a domain of -pi/2 to pi/2. And the range is -1 to 1. Now, to graph the inverse sine function, you just switch the x's and y's. And when you do this, you find you have a domain from -1 to 1 and a range from -pi/2 to pi/2. This is y is inverse sine of x. Now let's do the same thing with the cosine function. So first let me fill out the table. Cosine of 0 is 1, pi/6 1/2, √2/2, 0, -1/2, minus √2/2, minus √3/2, and -1. So when I graph cosine and I restrict the domain to 0 to pi, it starts at 0, and the range goes from 1 to -1. All right, so there's my 0. Now, to graph the inverse cosine function, switch the x's and y's. So 0, 1 becomes 1, 0. Pi, -1 becomes -1 pi. And sketch your curve. The domain is from -1 to 1 for the inverse cosine of x, and the range is from 0 to pi. Now, what if I want to graph the inverse tangent? Well, I'm going to restrict the tangent function from -pi/2 to pi/2. So if I were to plot these points, oh, see, this one does not exist. This one's -1, negative root 3 over 3, 0, root 3 over 3, 1, and does not exist. We have a vertical asymptote at these points. So the domain for the tangent is minus pi over 2 to pi over 2. And the range is from negative infinity to positive infinity. So when I switch the points and I graph the y is equal to the inverse tangent of x, I see I have a horizontal asymptote at y equal pi over 2 and y equal negative pi over 2. The domain is from negative infinity to positive infinity, and the range is from negative pi over 2 to pi over 2.